Today we're going to look at the last formulas that we have. So it's going to look like a lot, but it's really not. Kind of basic things that you're doing. So we've got double angle formulas. So if I've got sine of 2 theta or 2x or 2u or whatever, and we don't know what 2 theta is, we can break it down so that we can use just the sine and cosine of our variable. Same with cosine and tangent. There's also half angle formulas. These aren't on your sheet, so you should add these onto your trig sheet. If you want to put them on the back, that's fine. But these are not on there, and these you'll be using these. The thing for these, the plus or minus that's in front of here, the sign depends on which quadrant it's in. So I'm going to kind of draw you a picture here. Let's say we've got, okay, this is our angle. Okay, so my angle's over here. Well, if I cut it in half, the half angle is going to end up over here. Okay, so if this is u, then this would be u over 2. So if I'm doing like cosine, the cosine of u is going to be negative, but the cosine of u over 2, since it's in quadrant 1 and my x values are positive here, it's going to be plus. It's going to be a plus based on, because it's in this quadrant. Okay, so that's something you have to look at. Same thing for if we're down here. Okay, if I've got this angle and I cut it in half, that could put it up here somewhere. Okay, depending on. So since it's in third, if I cut it in half, it's going to be in second quadrant. Okay, because in order to be over in first quadrant, it's got to be in the second to start. Okay, and if it's in the fourth quadrant, that's probably going to put you, depending on where it is, might put you up in the second. Okay, or if you get down here, you can use the negatives. Just change them to the negatives. All you have to do for that is subtract it from 2 pi, and that'll tell you what the negative angle is. It might be easier to cut the negative angle in half than to cut the actual angle in half. There's power reducing formulas. So if I have sine squared u and I can't use my Pythagorean identity, and I want to change this just into terms of something else, okay, we can use these. There's product to sum. These, we have them. I don't really know why you would want to do this. You know, why you would change something from a product to something that's way more complex. So we've got these. I'm not going to stress them too much. It's just something else that's on your sheet you should know how to use. But really, for solving equations, it's much easier to have a product than some kind of complex sum or difference. So, I mean, they work, but probably won't use them that much. These are useful. If we have sum or a difference, we can turn it into a product. These are useful because it's easier to solve when you have a product. You know, if you've got something plus something equals something, it's not as easy as to solve as if you've got something times something equals something, because then you can cross multiply or get it equal to 0 and set each factor equal to 0. So these are useful. So let's go through some examples. I ended up not really using this, but we can make some examples up and use it if we want. So I know cosine of theta is 5/13, and it's in quadrant 2, which is why I oriented my triangle this way. This would be in quadrant 2. It also means that my cosine value, my x value here would be negative. So this should be -5. This would be 13. My y value is going to be positive, and this is a 5, 12, 13 right triangle. It's one of the Pythagorean triples. You could do Pythagorean theorem to figure that out also. So I've got this. If I want to know the tangent of 2 theta, well, I don't have 2 theta here. I have theta, right? 2 theta would be twice as much of this angle, so maybe something like that. But if if I double it, I'm not going to know what kind of right triangle that makes because it's not going to double, these measurements. Okay, so what I need to do is turn this into terms of theta. So I'm going to use my double angle formula, which is this. So I'm going to take 2 tangent theta over 1 minus tangent squared theta. So 2 tangent theta over 1 minus tangent squared theta. Okay, tangent theta is 12 over negative 5. So I've got 2 times 12 over negative 5 over 1 minus 12 over negative 5 squared. So that's what tangent theta is. So I can just substitute. So if I multiply this by 2, I'll get negative 24 fifths. This I'm going to square it out, so I get 144 over 25. I need to subtract that from 1. 1 is 25 25ths. If I subtract 144, I'm going to get, let's see, 14 minus 5 is 9, 119. So on the bottom of this, I've got negative 119 over 25. So to divide, we're going to multiply by the reciprocal. So negatives will cancel. We get 24 times 25 over 5 times negative 119, which comes out to be, let's do this with my calculator, 24 times 25 is 600, 5 times 119 is 595. Put those in a fraction and reduce it. It's 120 over 119. So I guess I could have just cross-reduced here. Got 5. Okay, so that's what the tangent of 2 theta would be. So from this point, I could set up another right triangle and say, okay, well, this is 2 theta. The tangent is 120 over 119. And go from there. I'd have to figure out which quadrant this was in, though. If I double this angle, if I double this, it's going to put it down in the 3rd quadrant, which means both of these would be negative. Okay, so that's just something else you could do if you want to take it a step further. Let's look at half angle formulas. Sine of theta over 2. Well, I don't know theta over 2, but I do know theta. Theta's in quadrant 2. So if I half it, I'm going to be in quadrant 1. So I'm going to make a note of that. This is quadrant 1. Sine values in quadrant 1 are positive, so that just means things are going to stay positive for me. My half angle formula is going to be the square root, the positive square root, since it'll be in quadrant 1, of 1 minus cosine theta over 2. 1 minus cosine theta over 2. Well, cosine is negative 5 over 13. So I've got the square root of 1 minus negative 5 over 13 over 2. Simplify the numerator. This would be 13 thirteenths, and I'm adding 5 to that, so I get 18 thirteenths. Over 2 is really just multiplying by a half. So I get 18 over 26, which I can reduce to 9 thirteenths. I'm square rooting that, so I'd have 3 over the square root of 13. It's positive because I'm quadrant 1. Rationalize this. I get 3 square root 13 over 13. And that'd be the sine of half of theta. All right, let's look at another one. I'm kind of skipping over the product to sum, just because those are just going to be straight application. It'll be say, okay, turn this product into a sum, so you just apply the formula. But the other ones are more useful because you can do more with them. So this one here, we want to find all the solutions of this. Right now, I don't have a way to find these solutions. I mean, I could pick a couple, right? Right now, I could see that when x is 0, this will work because the sign of 0 plus the sign of 0 is 0 plus 0, which is 0. So that works, but there's probably going to be more solutions than that. So pi would be another answer because I'd get 0 plus 0. But we want to turn this into something we can solve, so I'm going to turn this sum into a product. Okay, so when I've got sine of something plus sine of something, I use this formula. So 2 sine of the two things added over 2, and then cosine of the two things subtracted over 2. So 2 sine of 5x plus 3x over 2 cosine of 5x minus 3x over 2. So I've got 2 sine of, this would be 8x over 2, which would be 4x. This would be cosine of 2x over 2, which is just cosine x, equals 0. I can divide the 2 away, and now I've got something times something equals 0. So either this equals 0, or this equals 0. And since they didn't give me a range, I need to know all the possibilities. So I'm going to have to do that n pi thing. So I'm going to take the sine inverse of both sides, okay, and that's going to give me 4x equals the sine inverse of 0. Well, the sine inverse of 0 is 0 plus or minus pi n, because whenever I'm pi away from 0, I'll be back at a sine value of 0. Okay, and this comes from unit circle, so I'm saying that this is a solution, okay, because that gives me a sine value of 0. If I go pi away, I'm at 0 again. Pi away, I'm at 0. Or if I go back pi. Okay, so that's where the pi n. N is just an integer. Now I'm going to divide by 4. So x equals 0 plus or minus pi over 4n. So now I know that every pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, every multiple of pi over 4 is going to be a solution to this. I'm going to do the same thing here. X equals cosine inverse of 0, which is 1 plus or minus pi n, and that's your solution. Okay, so anytime I have 1 plus or minus pi, so 1 plus pi, wait, let's see, this would be, sorry, cosine inverse of 0. Cosine is 0 at pi over 2. Sorry, this is pi over 2 plus or minus pi n. This is your solution. So whenever I'm at pi over 2 or pi away from that, so here or here, so top or bottom basically. So these are your solutions. So if I want to list some possibilities for x values, pi over 4 is a solution, pi over 2 is a solution. In fact, this alone covers all of these, so really I just need this, because this is going to cover all the multiples of pi over 2. So I could have pi as a solution, 0 would be a solution, 3 pi over 4 is a solution, 3 pi over 2 is a solution, 5 pi over 4. Okay, all these multiples of, if I put any one of these in to this function, I'm going to get an answer of 0.